Good morning, ladies and gentlemen. So today we have one interesting discussion under probability, which concerns the Bayes theorem. So in discussion of condition probability, we indicated that revising probabilities when new information is obtained is an important phase of probability analysis. So often we begin the analysis with initial or prior probability that estimates events of interest. Remember, probability is all about estimating. Then from sources such as sample, special reports, or product tests, we obtain additional information about the event. Given the new information, we update the prior probability values by calculating revised probabilities. This is what is referred to as posterior probability, in other words, Bayes theorem. So under Bayes theorem, the Bayes theorem is given by the probability of A given B to be equal to the probability of B given A multiplied by the probability of A given the probability of B. So this is what Bayes theorem basically is. So someone who can ask to say, how is this formula derived under the Bayes theorem? So we know for sure that this, which is given as the probability of A given the probability of B, under normal circumstance, it is equal to the probability of A intersection B over the probability of B. We want to derive the Bayes theorem. So, having now known for sure that this is equal to that, let us assume one thing. What if we interchange B and A? Will the situation be the same? Remember, under sets, you know for sure that if a set is given to be this, where you have A and B, if they were to ask you to find the intersection of A and B, we will say A intersection B. We know for sure that that is correct for this shaded region here. So we know for sure that even this shaded region can also be represented by B intersection A. So meaning these two are the same, in other words. So what I'm trying to put across here is, let us think together. Remember, for you to be able to calculate the Bayes theorem, remember we'll try by all means to exchange B and A, but still we will need them to be the same. So if we interchange B and A, then our probability will read as the probability of B given A to be equal to the probability of B intersection A over the probability of A. This is what we know. Then, having known that very fact, we know for sure that in mathematics, A intersection B is equal to B intersection A under the commutative law under sets. Remember the commutativity of sets. B intersection A is the same as A intersection B, or B union A is the same as A union B. So what we'll do here is we'll cross multiply. So this to that, we'll have the probability of B given A to the probability of A, and this will equal to the probability of B intersection A. So having dotted that in our preamble, so let us now replace what we have here to what is here. Remember, we are from stating that the probability of B intersection A is the same as the probability of A intersection B. So we know for sure that we are working now on equation 1 and equation 2, the ones we are from deriving. So for us now to be able to go to a conclusive understanding and solidifying things under the Bayes theorem, let us replace the probability of B given A to the multiplied by the probability of A. Remember, these are the same. So now we just replace there. So the probability of A given B is equal to, remember, this is equal to that. So we just replace the probability of B given A multiplied by the probability of A over the probability of B. So this is what we had in our preamble when we said that the Bayes theorem, this is equal to this expression, the one we are getting, these two, they are now the same. But there are times whereby one can ask to say, how do you find the probability of B when you are not given in other words? So let us go to conditional probability under the set theorem when we are dealing with probability. Remember, for you to be able to find the probability of B, what you can do here is you can say, for you to be able to find the probability of B, the probability of B is found by the probability of B intersection A complement, where this is equivalent to the probability of B minus the probability of A intersection B. So this is what we have when we want to deal with this. So remember, under normal circumstance, the probability of B is equal to the probability of B. So let this go to the other side so that we can remain with the probability of B. So we have the probability of B intersection A complement plus the probability of A intersection B to be equal to the probability of B. So having arrived at that conclusive understanding of what these two are representing, what is the probability of A intersection B? The probability of A intersection B is what you had on top to be the probability of B given A times the probability of A. So this is also given by the probability of B given A multiplied by the probability of A. Remember, we are now remaining with us interpreting the other part. So how do you interpret the probability of B intersection A complement? We know for sure that for you to arrive at this can also, under conditional probability, be given by the probability of B given A complement to be equal to the probability of B intersection A complement over the probability of A complement. This is what we have. So having done this, so here we can multiply and we'll get the result to be the probability of B given A complement multiplied by the probability of A complement is equal to the probability of B intersection A complement. So this is the very fact that we have. So we know now for sure that these two are the same. So where we have the probability of B intersection A complement, we can also have the probability of B intersection A complement, and we'll add it to the very result for us to get the probability of B, as our formula has stated down here. So we know for sure that now that we have the probability of B intersection A complement, we can replace it with this which we have. So we'll have the probability of B given A complement multiplied by the probability of A complement. So that's what we have. So now that we have this expression, we can just replace it down here so that we can derive what is referred to as the Bayes theorem expression. So we know for sure that now the Bayes theorem is defined by A given B is equal to the probability of B given A multiplied by the probability of A over, where B now is the probability of B given A complement multiplied by the probability of A complement plus the probability of B given A multiplied by the probability of A. So this is the Bayes theorem formula in full. So this is how you derive the Bayes theorem. So if there is any question on how you want us to derive the Bayes theorem, or if you want us to just leave it there, even here, it is still defined as the Bayes theorem. But we know for sure that people normally love this one because you are always given an event of 2. So this is our first video on Bayes theorem. So the next video on Bayes theorem will basically deal with examples, and I will attach the link in the description of this video on how to go about some certain examples on how to handle Bayes theorem. Your host, Golden Zulu.